Hi guys, welcome back to lesson 14.3, where we're going to talk about the difference between even and odd functions. Lesson 14.3 is on page 237 of your Springboard book, and you will want a pen or a pencil. All right, so we are going to recognize even and odd functions given an equation or graph. So we'll be able to recognize them both ways. And then we are going to distinguish between even and odd functions and even degree and odd degree functions. Okay. So it says here, the graphs of some polynomial functions have special attributes that are determined by the value of the exponents in the polynomial. Okay. So first of all, we have the graph f of x equals 3x squared plus 1, and that's graphed over here. And we have the graph of f of x equals 2x cubed plus 3x, and that is, graphed over here. Okay, so first of all, number 2 says, describe the symmetry of the graph of f of x equals 3x squared plus 1. So that's the one we have in red there. So in order to describe that symmetry, it's a quadratic. It's what we were actually looking at in unit 2. And we would say that this is symmetric about the y-axis. Because if you folded that parabola right on the y-axis, it would be perfectly symmetrical. So symmetrical about the y-axis. Awesome. Okay, then if we take a look at number 3, it says describe the symmetry of the graph of f of x equals 2x cubed plus 3x. Okay, and what happens here is this shape is exactly the same as this shape. It's just kind of flipped over the x-axis and then also over the y. So what we call that is actually symmetric about the origin. Okay, origin. So you guys know the origin is that point 0, 0. So if you can see that there. So it is symmetrical about that point instead of the x-axis or the y-axis. It's symmetrical about that point. Okay. So what we're going to be talking about today is whether a function is even or odd. So it says here the function f of x equals 3x squared plus 1, which was the red one, is called an even function. Okay. So in other words, this one here is even. Okay, because it's symmetrical about the y-axis. It says, notice that every power of x is an even number also. So for example, 3x squared, that is an even number. And then 1 is a constant. So we can think of that as like x to the 0. So that's also even. So that's what makes this an even function. Okay. All right. Then it says here there is no x to the first power term. There's no x cubed term. So this is true for the constant term as well, since you can write the constant term as the coefficient of x to the 0, like I just showed. Okay. Symmetry over the y-axis is an attribute of all even functions. Okay. So anytime you see a function that is symmetrical about the y-axis, you know it's even. And if all of the exponents are even numbers, then you also know it's an even function. Okay. So similarly, the function f of x equals 2x cubed plus 3x is an odd function. So we could go ahead and say now that this means odd. And that's going to be that one there. Okay. Notice that every power of x is an odd number. There is no x squared or constant x0 term. Okay, so we can see we've got an x cubed up here. And technically, when it's just an x, that's like an x to the first power, right? So 3 and 1 are both odd numbers, so that makes sense. Okay, so now we also know that symmetry around the origin is an attribute of all odd functions. Okay, so now we can kind of tell, okay, graphically, we know what the symmetry should look like. And looking at the equation, we know what the exponents should look like to determine whether it is an even or odd function. Okay, so this part down here is super important. I would definitely jot this down. Okay, so all of this right here tells you whether it's an even, odd, or neither function. Okay, so an even function, all exponents are even numbers. We talked about that. There will be symmetry over the y-axis. And as we talked about in the last video, the end behavior will go the same direction. So they'll either both arrows will be pointing up or both pointing down. Okay. With an odd function, all exponents are odd numbers. The symmetry is around the origin and it will have opposite end behavior. So as we see here, one is pointing up, one is pointing down, or vice versa. Okay. And then last, there are functions that are neither even nor odd, and those have a combination of even and odd exponents. It is not symmetrical over the origin or the y-axis, and the end behavior could be the same direction or opposite directions. Okay, so that's kind of just a quick way to tell whether a function is even, odd, or neither. So again, if you didn't have enough time to jot this down, I would pause the video and make sure you have it written down. Awesome. So let's try some examples here just by looking at the function. So in the last, on the last page, we saw the actual graphs, but let's go ahead and just do this by looking at the equation. Okay. So in number 1, we have x to the 5th minus 7x cubed plus x. Okay, and the first thing I would do is realize, okay, this x is like an x to the first power. It's a linear term. We're going to write that as x to the first power. So then I would go ahead and say, okay, let's take a look. We have a 5, a 3, and a 1 as our exponents. So that tells me that we are looking at 5, 3, and 1 are all odd numbers, so we are looking at an odd function. Okay. Then let's go ahead and do the same thing with the next one. We have 3x to the 4th, negative x squared, 9x, which again is linear, so we're going to put a little 1. And then we have a constant, which we can think of as x to the 0 power. Okay. All right, so now, again, let's go ahead and take a look at all the exponents. We have a 4, a 2, a 1, and a 0. Okay, well, 4, 2, and 0 are all even, but 1 is odd. So this one is an example where there are some even exponents and some odd. So we would say this is neither an even or an odd function. Okay. All right, in this next one, number 3, we have 9x to the 6th minus 3x squared plus 8. 8 is a constant, which means that's going to look like x to the 0. Take a look at your exponents. 6, 2, and 0 are all even. So this is an even function. All right. And last one here, we have 3x to the 4th minus x squared plus 5x to the first power. And if we go ahead and look at the exponents, we have 4, 2, and 1. So 4 and 2 are even, but that 1 is odd. So this would be a neither. Okay. All right, so again, you could also determine these by graphing them if you wanted to graph them in your calculator, or if you wanted to do it on Desmos. And then just remember, if it is symmetrical about the origin, it's going to be odd. If it's symmetrical about the y-axis, it's going to be even. And if it's not symmetrical about either the y-axis or the origin, then it's a neither. Okay. All right, last up here, I want you guys to answer number 6. So explain why the function f of x equals 4x squared plus 8x is neither even nor odd. Okay. All right, that's pretty much it for today. So we will do some practice with this in class tomorrow. But other than that, have a great day.